We know that the body has moved if it has changed position over a given time. We can describe motion as either fast or slow, but these are relative terms. What is fast to one observer may be slow to another. Therefore, a more quantitative description is required. In quantitative terms, we describe motion of a body by giving it speed. Now, speed is the ratio of how far a body has traveled or the distance traveled over how long it took to traverse that distance. So, in here we have the speed is equal to distance traveled divided by the elapsed time. In symbols, we write that as delta S over delta T, where delta S is the distance traveled, delta T is the elapsed time, delta means the change in. In track and field, for instance, in the 100-meter dash, the winner is the sprinter who clocks the shortest time because his speed is the greatest. A runner does not move with the same speed all throughout the race. He starts at 0, speeds up at the sound of the gun, and would run at varying speeds until he reaches the finish line. To describe the runner's motion, his average speed is given. Now, physics teachers, we have another definition to make. Average speed. Average speed is the total distance traveled divided by the total time. And for the runner considered, his average speed will be equal to 100 meters divided by 10 seconds, and that amounts to 10 meters per second. Vehicles, like cars, have in their instrument panels a meter called the speedometer that reads the car's speed at any given time. These two cars have the same speedometer readings, but they are headed in opposite directions. So, to give a complete description of each car's motion, it is important to indicate the direction of the motion. So one car is moving 20 kilometers per hour east, and the other car moves 20 kilometers per hour west. A description of how fast the car is going and which direction it is headed is referred to as velocity. Such quantity, which has both magnitude and direction, like velocity, is called a vector quantity. On the other hand, speed, which has magnitude only, is called a scalar quantity. In simples, the speed is symbolized by the letter v, while velocity, which is a vector quantity, has the same letter v, but with an arrow on top. Now, how do we measure average velocity? Okay, we have a cyclist here, and suppose the cyclist travels a straight path to the east, like this, and he goes back to the finish line, which is at the 40-meter mark. Okay, now, we can see that the total distance traveled by the cyclist from the starting line to the 100-meter mark up to the finish line is 160 meters. If he travels this in a time of 20 seconds, therefore the average speed is equal to 160 meters divided by 20 seconds, which is 8 meters per second. Now, given the average speed, we are faced with other questions, like in what direction did he move, where is he after 20 seconds, and from the given situation, at the end of 20 seconds, the cyclist is 40 meters east of the starting point. In physics terms, we could say that his displacement is 40 meters east of the starting point. Okay, so now we encounter another term that needs to be defined and explained: displacement. What is it and how is it related to velocity? More on this when we return. Fellow physics teachers, welcome back to the show. To pick up from where we left off, what is displacement? Displacement is the change in position with respect to a reference position. It is the straight line distance from the reference position to the final position. And it is represented by an arrow, this particular arrow, up to the finish line here. The cyclist's average velocity is the ratio of the displacement and the time taken. Okay, so the average velocity is equal to delta S, which is the displacement, over delta T, and that is 40 meters east divided by 20 seconds. Therefore, if you compute that, the average velocity is equal to 2 meters per second east. Now, supposing the starting and the finish lines are the same, what is a cyclist's displacement at the end of his trip? And what is his velocity? Displacement, like velocity, is a vector quantity. Both have magnitude and direction. On the other hand, distance and speed are scalar quantities. Now, as you can see from our previous examples, the magnitude of the displacement is not equal to the distance, nor is the speed equal to the magnitude of the velocity. The distance is equal to the magnitude of the displacement, and the speed is equal to the magnitude of the velocity only when a body moves in a straight line in one direction. So you can see here from our example, we have written down this is your distance, which is 160 meters, and this is your displacement, which is 40 meters east. On the other hand, your speed is 8 meters per second, while the velocity is equal to 2 meters per second east. A runner is concerned with how fast he is running. That is speed. On the other hand, the car driver is concerned with how fast he is going and the direction he is headed for. That is velocity. To review our definitions, distance is the length of the path traveled. Displacement is the change in position with respect to a reference point. It is the straight line distance from the reference point to the final position. Speed is the description of how fast the body is moving. And finally, velocity gives a description of how fast and in which way a body is moving. So, how can today's lesson be applicable to everyday life for us and our students? For one, knowing concepts in motion and how to tell direction will help us find our way when we are lost or to locate a place when given a map. It allows us to make fairly accurate estimate of the distance between two places given the average speed and the estimated time to reach the place. And given the estimated distance from one point of origin to a point of destination and the given estimated average speed, we can easily derive an estimated time of arrival. So, till next week then, this is Dr. Zenny Domingo for the first TV program for physics teachers like us, Physics in Everyday Life. Have a good day. Bye.